Okay, with any luck, this should be the last of my series on data visualization using ggplot. This is, of course, not even close to the whole, covering the whole of what ggplot is capable of. The point of this module was really just to give you an introduction to it, to teach some of the basics, but also to introduce you to a lot of the core ideas of using R in general. So as with all of the previous ones, I'm working over here in this RStudio Cloud project, which is also over here. So where I want to start is to pick up at the end of these exercises that I suggested that you do at the end of the previous one. So if you remember from the previous section when I was talking about doing these exercises in emoji translation, and then I gave you suggested having a look at this data that we collected on forensic handwriting expertise. And basically, to give the super short explanation of what's in this paper, is we, and by which I mean Christy Martiri and Bethany Groans, who did all the real work on this, went out and got a bunch of people who are actual handwriting experts and a bunch of novices to look at some pieces of text like handwriting and say, okay, well, this feature in the handwriting, this squiggly T or whatever, I don't know, is that how common is that in real handwriting? And basically say what proportion of real world handwriting samples would contain that feature. And they had to give an answer from 0 to 100, and then this could be compared against the true base rates, or to see how well calibrated novices and experts are. That's the gist of the study. There's a whole lot of additional details about exactly how it was set up that I'm going to skip, but at least now you've got a sense of what the data is you're plotting. So in exercise 9, I gave you this to plot. Right? I gave you some code that should have generated this plot, and it's worth having a little bit of a discussion of it. So here's the code that I would use to draw it, like a very minimal version of it. Library tidyverse, we load the data, and here's our ggplot, right? So we've got ggplot data equals forensic, like the forensic data set that I've loaded up here. So we go that plus geonpoint, and we've got a mapping here that says on the x-axis we're plotting the true frequency for that feature, and the y-axis we've got the estimated frequency. That is what the participant gave as their response. So when I Control Shift S to source that, what I see is this output over here, where I've got this kind of, it is technically a scatter plot, but what you can see is that the x-axis comes with these bands. So this was a built-in feature of the design. Christy and Bethany, when they designed the study, said, well, what we want to do is have a bunch of features that are whose true base rate is about 1%, others that are about 25%, others that are about 50%, others that are about 75%, you can see there's a bit of variance around this one, and others that are about 99% frequency. So although the true frequency of a handwriting feature is a continuous valued variable, what we've really got is something that comes in these discrete ordinal bands, and a scatter plot is not really the best way to draw the data here. So what we might do instead is have a look at the data. So I'll just clear my screen here and go forensic, and oh no, forensic is, there we go. So here's all of our data, which has 6,000 odd rows. We've got a whole bunch of variables, and you'll notice when this bit down the bottom that's saying there are 8 more variables. Aha! Look down the bottom here, we've got est. That's the true value that we were plotting on the y-axis. Sorry, that's the participant's response. True is the value that was on the x-axis. Band is gives you a sense of it specifies which of these bands it belongs to. Now it's kind of annoying that we can't see that, so one thing I'm going to show you, which you may have discovered on your own, but if not, if I just click on forensic there, it'll bring up a nice pretty table that I can go and inspect. It's the same data, it just gives me something, a prettier version I can look at. So if I go over here, what I discover is that band is just some categories. Band 01, band 25, band 50, and so on. So that's what that variable is capturing, and that's the thing that we want to plot instead. So okay, what I want to do then is I will change the x-axis. Instead of plotting true on the x-axis, let's plot band instead. So we save, Control S, we source, and okay, that's a slight improvement, but only in the sense that it picks out the relevant bands. It has given us still a scatter plot. Well, the exercises probably gave you some hints to what to do there. We changed the geom. Instead of using a geom that just plots all the points, why don't we instead draw a box plot? Box plot. Right, and I go box plot, we save, do the same thing, and now we get something here where each box plot, if you haven't seen box plots before, but probably most people have, the thick bar there is the median response, the box around it draws the interquartile range, and then these whiskers show the full range of the data. Little dots out here are kind of outliers. I don't like the term outliers in this context because there's a crude formula under the hood that's used to say, are these observations sufficiently far away from the body of the observations? And if they're too far away, we don't call them really part of the distribution. There's a whole statistical theory around it, which I sort of think is a bit... It's not well suited to the kind of data that we've got here, so I would tend to just ignore those here and say there's nothing wrong with these points, they're just part of the data. Another way of drawing much the same thing is to try a violin plot, which is essentially violin, that won't work, violin, which will redraw the same thing, or the same idea, and it tends to just try and give you a smooth density estimate of the distribution of points. You can pick and choose what things you like. For the purposes of this data, I'm actually going to go back to the humble box plot, and we're going to use that for motivating the rest of this thing. So what I suggested as the solution in exercise 10 was, let's just draw this as box plots or violin plots or something. Okay, the problem that we have now is that this is a nice way of representing the data that we got from each person, or across all the people, as a function of the band. So the very low frequency features, the middle frequency, and these are the high frequency features. And overall, what we're seeing is, yeah, people know that rare features are rare, and they know that common features are common, and they don't really know much about the ones in the middle. But the point of the study was to compare novices and experts, and at the moment we've got them all bundled in together. To split them up, what we really want to do is break this plot into two subplots, one for the novices, one for the experts. In ggplot language, the subplots would be called facets, and there is a function there called facet wrap, which allows you to specify, to break things up into these facets. So what I want to say is that the variables, or vars, I'm going to skip for now the explanation of why I'm using vars here. For the moment, let's just take it on faith that when I say facet wrap, we go vars and then we give the name of the variable that we're going to use to do the faceting. I will revisit that, I promise, but that's not going to be for until a much later date. For now, we just put in vars. So we say that, well, let's just break it up by handwriting experts. So now you've got the experts on the left and the novices on the right. And you can kind of see by eyeballing it that the experts actually are a little bit better than novices. Like the median response, if you compare the zero band, or the band 01 here, their median is really close to zero, whereas the novices, not so much. Overall, the experts actually do seem to do better at telling the difference between common features and rare features. So I will, I forgot that I was about to move on. So let's go back to my code and quickly do the same thing. So repetition is always useful when you're getting started. So we go plus, facet, and I'll wait for that to come up. You'll notice that there are a few different faceting functions. I'm not going to go through all of them, but at some point you might want to use facet grid. So here's facet wrap. And if I wanted to name my argument, I could say facets equals vars, and I'll say handwriting expert, is that what I called it? Let's find out. And hey, we got the plot that we wanted. Okay, so this is a perfectly serviceable plot that does most of the things that we want, right? It shows you the distribution of responses for the experts and for the novices, broken up sensibly by band. This captures the fundamental thing that we wanted to look at in the study. Yay! We are done, in the sense that we found out the thing that we wanted from a scientific point of view, which is, yeah, okay, experts are a bit better than novices. Okay, there was more that we cared about in the study, honestly, there really was, but the point is, this plot is functional, but it's not pretty. Like, all the labels are sort of jammed in. I'm not happy with the x-axis labeling or the y-axis labeling, and I can't even remember what's x and y. Like, I want prettiness. I like pretty plots. Pretty plots are easy on your reader, viewer, audience, whatever. If I want to publish this, if I wanted to put it up as an infographic or just publish it in a scientific paper, I actually have to do a bit of extra work. And so the last thing I want to talk about before ending this section is the basics of what I sometimes like to think of as glamour graphics, the pretty stuff. And I most certainly did not come up with this term myself. I am shamelessly stealing from Will Chase, who gave a very excellent talk at our studio conference not all that long ago. So this was February 16th, and I'm recording this in March. So this was a great talk. I thoroughly suggest at some point just click on this, watch Will's talk. It's awesome. I love this talk. But he'll cover a lot of things about how you should think about designing good charts. And I'm not going to cover that here, but listen to Will. He's great. Okay. Enough fangirling. I'm going to go and talk a little bit about how this is just the plot that I just created, right? With one other thing added, sorry. The first thing I want to do, okay, is add a little bit of color. I like color. So the fill aesthetic is what I'm going to use here. I just say that the fill associated with each box plot, we're going to map that onto to the band variable. So now we've got red for band 1, the kind of olivish color for band 25, and so on. This is nice for a couple of reasons. First, it makes it easier for your audience to do a kind of apples to apples comparison. I automatically want to compare the two red things to each other, the two purple things to each other, the two blue things to each other, and so on. Of course, I'm not colorblind. So for me, all of these colors are completely distinguishable. The default color palettes in ggplot are not always colorblind safe. So one thing you should generally do when creating plots is, yes, use your color to help convey things to your audience, but also make sure, just print it out in grayscale and check that it still makes sense. And you can also look into colorblind safe palettes and things like that. There's a bunch of actually really good resources on this, but for now I just want to say, remember that color blindness is a thing and that black and white printers are a thing. Don't rely on color to do all the work for you, but nevertheless use color wisely, because color is great. Okay, enough on that. Let's go back over to my actual code, and I'm going to do the same thing over here. So I'm just going to go over here, we'll go X, Y, and then I'll add my fill aesthetic equals band as well. Okay, so I'm going to run the code over here. This is the exact same code, and this is useful for a couple of things. Firstly, I just wanted to do it to call attention to something else. That notice that I actually have this nice little legend now that gives a cute little thing saying, "Hey, we've got the little red box plot as Bando One," and so on. Um, and it's kind of more readable than the text over here. Like Bando, all the text is kind of running into each other here, and maybe what I want to do is kind of just make it go away. So let's talk about make the bad text go away. Okay, so first thing I want to do, I forgot. Sorry, I forgot what order I had things on my slides. I'm going to make the bad text go away, but first let's make the bad background go away. Now, people have different opinions. The default theme in the default background colors in ggplot are these grey colors. They're perfectly serviceable. If you want to just sort of say, can I have something a bit more minimalistic? You can take the same plot and add theme minimal to it. And this will give you, like, I think that this is a visually more appealing plot, which is kind of cool. But one thing, hold on, I gotta go back to my thing. Alright, so one thing I want to call attention to for the moment is over here, I'm just gonna make my script go away for the moment. I'm gonna make this go away for the moment. Over in the environment tab over here, when I've got the list of my variables, if I just type at the console, this is a thing I haven't shown yet, but it's sort of useful. If I just type picture, it draws the picture. It's giving me this warning, and I'm going to come back to the warning later on at some point. For now, just notice it's removing some missing values is all you really need to care about. But remember how I can actually go picture plus. If I wanted to go, let's say picture plus theme minimal, I can take the same object and I can just keep adding things to it. I could instead have said theme dark, and that would give me a plot that looks like that. And the thing I want to point out with this is that pictures, so this thing here, which was the ggplot object that I created back up here in my script, I can just keep adding to it later on. So I could, for instance, if I wanted to do this, I could go picture whatever 2 is picture plus. I'm not actually going to do that, but I want to point out that you can do things like that. Okay. In the slides, the only reason that I'm doing that is just to because I don't have room on the slides. When I'm doing my actual code, I'm going to tend to just keep it simple like that. So I'm going to go back over here and plus theme minimal. So now we've got a version when I just Control Shift S to source it. This is producing the same thing in the script. So in my slides. So the script and the slides are now doing the same thing. It's just that in the slides, I'm just going pick plus theme minimal because that's all I can fit on the slide. Okay. Now, I did promise, I wanted to say, remember the bad text. I want the bad text to go away and leave me alone. Okay. The way I can do that is by modifying the scale. So I can just take on the x-axis, because we had a discrete variable plotted on the x-axis, there's a scale x discrete function that I can use, and what I've just said here is go names equals null, and that's going to, when I go names equals null, I remove that band bit. Then I can go labels equals null, and that will remove the it removes the bad text. So when I do that, I have cleaned up part of my plot over there, and I can extend that a little bit further and get rid of the names on the y-axis. So let's go back over here and do the same thing. Go plus scale x, I'll just down there discrete, and what did I say? I am have a bad habit of forgetting what I'm doing. And so if we go over here, we go name equals null, and label equals null, and we source, and that cleaned up our x-axis like we said we wanted to. Now let's do the same thing on the y-axis. Go scale, and remember on the y-axis, oh, there's a whole lot of things here, so I'll just go scale y continuous, because we've got a continuous value as our y-axis, and I'm just going to go name equals null, save it, source it, and that removes that est thing. I could do it that way, or if I really wanted to, I could give it something more readable. I could go estimated probability. Actually, I'll just call it estimate. And we source that. That seems like a nice enough name for it. I'm going to leave it like that in this version. I think in the script slides, I left it null. But what I did do over here, what I would also often want to do is have a title. Plots need titles. Okay, so to give my plot a title, what I need to do, let's go back over to source, is go back over here and go plus ggtitle, and let's go label. So the label and the title is going to be handwriting. I can't spell. Writing feature prob estimate for experts and novices. This is slightly different to what I have in the slides, but whatever. You can give different things. So if I go source, and yeah, that'll work. I'm going to use that for this one. What I will do is go comma. Now my code is getting quite big, so let's just go back over here and give ourselves some room to see what I'm typing. What I didn't show in the slides, I'll show here. I can also add a subtitle. Source Martiri et al. And I'm not going to put the year number in because I'm lazy, and also because I've forgotten whether it was last year it came out or the year before, and that's embarrassing. So when I go source again, you'll see here source Martiri et al. Appears there. So you can add a title and a subtitle. This is starting to look a little bit nicer. Okay, I'm going to just say handwriting estimates for features and novices. I lied, to make it a little bit smaller so that it fits nicely on my screen. These sorts of considerations matter when you're creating plots. You know, what is going to fit on the screen? What looks good? What can you take as assumed knowledge, etc., etc. Okay, let's go back to where I was up to in the slides. Okay, so the next thing I want to do is kind of go, I don't like those colors. I would like, I just don't, frankly. I find them a bit meh, and I did complain about, bad color palettes a lot, so I should show you how to get prettier ones. So the way that I got a color palette is in the same way that fill and x-axis and y-axis are all aesthetics, every aesthetic is associated with a scale. So x-axis has a scale, y-axis has a scale, so does color, so does fill, so does shape. You get the idea. Everything, aesthetics have scales associated with them, and you can modify those scales using the scale functions. So what I'm going to do here is use the scale fill viridis, viridis d for discrete, function to create this nice this smoother looking colors. So let's go back to my plot over here, and we'll go plus, scale, fill, and you can see there's a lot of options here. I'm going to go gosh, there's a lot of them. Viridis D is what I want, and that'll do for now. So save it, source it, and this is looking nice, right? This solves a bunch of problems, like it gives me this feeling that there's some continuity from left to right, and these are a little bit more colorblind friendly in some ways because the brightness also varies in a coherent fashion from left to right. But we've introduced a new problem, which is that I can't see the median over here, and it's not just because I'm wearing sunglasses at night, it's because it's just not like dark. A lot of ways I can solve that. One thing you can do is, I'll just hit tab here and go, ooh, alpha. Alpha is transparency. Let's make this 50% transparent by just making that 0.5. Save that. Control Shift S, and now you get these partly see-through colors, and that's kind of nice. I find that visually more pleasing, and you can also see all of your box plots and the medians and so on. Okay, go back to the slides. That's what I did in the slides. You just add this additional argument and so on. I'm gonna also notice that the legend up here has got band in it. It's kind of redundant because the labels already have band in it. Well, guess what that is? That's the name of the scale. I can set that to null. Let's go and check that over here in my code and go name equals null. I'm really not good at that. Yay! There we go. And it goes away. We like to make the bad text go away. Generally, if there's not useful text, make it go away. There's a whole lot of people who say things like, oh, you should never have any text at all, or as minimal text as possible. I tend to think some text is handy, but work out when you really need the text is basically the thing I want to convey here. Okay, so we've got most of what we wanted, right? Like this covers almost everything that we need it to. We've broken it up into facets, we've given things nice names. The one thing that I haven't done that would make this a genuinely decent plot is show you how to get rid of that annoying extra space. The extra space there has to do with the fact that, remember you were getting that little warning message and saying that, oh, it was dropping values. There's some missing data in the original data set, and R is not handling that very well. At a later point, I'm going to show you how to remove that, and I'm also going to show you how to do things like, can we, instead of having HW expert, have it say experts and novices? But at that point, I think we've got a pretty graph, right? I would be reasonably happy with this and not ashamed to admit that I created this and I put this in a paper somewhere or something. And that's about the point that I really wanted to get to with this series. And so I think that's basically it as far as my intro to plotting goes. Next section, I'm going to talk about basically the ins and outs of getting data into R, and I'm also going to introduce a few other fundamentals of the language. But as a general thing, where should you go next? If you want to refresh it, well, I mean, you can always go and listen to these videos again, but usually you want something new. This is a good beginner's tutorial. It's very nice. There's a book, R for Data Science, by Hadley Wickham and Garrett Grolleman. I think that's how you pronounce his name. Sorry, Garrett. It's a great book. It's brilliant. This has got a whole bunch of stuff in it. It's got some things on data visualization specifically that covers exactly this stuff. If you want my stuff, but like with more detail, I once wrote an advanced workshop that you can find here. If you want a whole book on data visualization, Kieran Healy's book is excellent. I really like his book, and you can find it for free online there. And that is everything that I have to say on this topic. Enjoy ggplot. It's fun. I like it. And I may or may not see you elsewhere. Right? Oh, shut up now. I promise. Really, shutting up. Pushing this button. Bye.